This lesson has two parts. One of them is multiplying a monomial and a polynomial, and the other one is basic factoring of a polynomial. Let's start with this, multiplying a monomial and a polynomial. And I'm going to start with these as an example. Negative 3x, 2x cubed, plus 7x squared, minus 3. In a way, multiplying with a monomial is pretty easy because it's nothing more than simple distribution. We're going to take this monomial here and we're going to multiply it to each one of these parts of the trinomial here. And that's what the parentheses means. If there's a number outside here, you're literally just multiplying it into those parts. So, negative 3x times 2x cubed, well, the negative 3 times the 2 gives me a negative 6. The x times the x cubed gives me x to the 4th power. The negative 3x times the 7x squared, I do the same thing. The numbers, or the coefficients, I'm going to multiply those to get a negative 21. And then I'm going to multiply the variables, which means adding the exponents, because I have one of these and I have two of these, and so together I now have 3 of those. And then I'm going to multiply it times this one. The negative 3 times the negative 3 makes a positive 9. There are no x's here. That's the same as an x to the 0 power, and 0 plus the 1 here means there's just one x. So that x just sort of comes along for the ride now. And that is the result of multiplying this in. This is not a hard thing to do. It's just a matter of being careful with negatives more than anything else, and making sure you keep the coefficients which you're multiplying to and adding the exponents of the x's. All right, now, here is a second one. 7x squared, 2x squared, minus 5x plus 4. If you're watching this on a video, take a moment to do it yourself. Pause the video, work it all out, and then come back. I will start talking again in about 5 seconds. Alright, so what we do here is, again, same as this other one. I'm going to multiply to that to make 14, x to the 4th power. Going to multiply here to make that negative 35, x to the 3rd power. And then to here to make that plus 28, x squared. And if I'm careful with negatives, I see there's 1 multiplied by a positive. That looks good. 4, 3, and 2. That looks like the correct answer to me. So that's 2 of these. Now, let's take a look at the next part here. That, you can see, is not a hard thing. The next part involves what's called factoring, basic factoring. And that means taking out something that's common to all the terms. It's actually nothing more than the opposite of this one. Here we put this in, now we're going to take it out. So here is the second one, and we're going to start with this example. It's going to be, in fact, the word that's used is factor. And that is, we're going to take a common factor from this. Let's use this example, negative 6 x to the 4th minus 21x cubed plus 9x. You'll recognize it because we used that on the last page. What we're going to do is we're going to look at it and figure out what is common to all 3 of them at the same time. So looking at the numbers, negative 6, negative 21, and 9, I see I can't divide them by 2, but it looks like I can divide them all by a 3. I can't divide them all by a 6 because that doesn't work with the 9. I can't divide them all with a 9 because that's larger than the 6. But I can divide them all by a 3. So the method I use that helps me keep track of this is I set up a denominator underneath each of them, and I'm going to put that 3 because later I'm going to divide them to get a result from that. So 3 does go into each one of them. Also, when I look at the x's, I see that all of them have x's. And that means that I can take however many x's out that they all have. This has 4, this has 3, and this only has 1. But that means that there's 1 that's common to all of them. So I'm going to go like this. Now, the fact that this is negative is something I also want to think about, because I can do this without making it negative, but the first one I like to have as a positive, and I should have as a positive. So what I'm going to do is I'm going to make sure that when I'm dividing here by 3, I want to divide them all by a negative so that the leading term is going to be positive. That one should end up as a positive. So, just like when we did this on the last one, we had that number in front of it. That's what we want to have. We need to put the number in front that we're taking out of all of these. So I'm going to take out here that negative 3x. And I put this underneath so now I can divide things. The negatives cancel, 3 goes into 6 twice, and this x takes away one of those. That means this is the result of taking out this common factor for this term. Now I'm going to take this common factor out from this term, and I'm going to do the same thing. The negative and the negatives cancel, so this will be a positive. 3 goes into 21 7 times. That's how I get my 7 here. And so there's 3 x's here, but this x will take one of those away. So now I get x squared. And here, a negative and a positive, well, it doesn't cancel out. That means this will be a negative. 3 goes into 9 3 times, and the x's just simply cancel. So I could put a parentheses here. So I get 2x cubed plus 7x squared minus 3 with the common factor of negative 3x in front. And that would be the answer. I have just factored this. I took this one and I broke it down into 2 things that will multiply to make it back again. Now, let's look at another one before I give you one to practice here. Or actually, I guess I'll give you this one and give you a few seconds to try it yourself first. So I'm going to give you 13ab to the 3rd power plus 39a squared b to the 4th power. Try to find a common factor for those 2. There's only 2, not 3 this time, but that's okay. We'll do it with 2. So do it yourself for a few moments, pause the video, and then come back. I'll start talking here in about 5 seconds. Okay, now let's take a look and let's see if you found here what was common. 13 and 39 might not be used to those numbers, but 13 is actually 3 times that. So 13 goes into this once and it goes into this 3 times. So 13 is actually a common number. 13 is common to both of these. They both have an a. This one happens to have 2 a's, but at least there's one a that's common to both of them. And here, this one has 3 b's and this one has 4 of the b's. Well, it's as many as possible that they both have. So I'm not just going to put 1 b here, I'm going to put 3 because there are 3 b's that are common to both of them. Now I'm going to set it up with the parentheses, and if this is correct, I'll get a nice result here, something that'll make sense. 13 and 13, well that's 1, this is 1, this is 1. In fact, this is the same thing. So this divided by that is simply 1. Plus, 13 goes into 39 3 times. This a is taken away from that, so there's only 1 a left. And these 3 b's are taken from that, so there's only 1 b left. And that means that these 2 polynomials had this as a common factor. It doesn't mean this is 0. Some people forget and think, oh, well, it's just gone, and they just do this, and they don't even include the 1. So you don't want to make that mistake. You don't see this all the time. Sometimes you will see it, and you want to remember that it actually is a 1 that's in there. And so now we have taken this one, and we have factored it, so we have a common factor for both of those, and this is the result of it. We could go backwards now and multiply this to this, and multiply it to that, and we would get back to that same thing. Okay. So that gives you now in this lesson, let me put a box around it to show that that was the answer for it. So in this lesson, you were able to see how to multiply a monomial and a polynomial. So multiplying this into it. And here, you were taking out a monomial. Factoring it is, first factoring is common factoring. Now, other lessons will go into other ways of factoring, but this is the first and probably the most important thing, because it's most common, of seeing that if there are common numbers and common variables, you can take that out. But it has to be common to every single one of the terms. And they were in this case. All right. So make sure you remember about taking out each one of the numbers and variables that are common to each of the terms.